Hi guys, so this little video is about Hess's law and how we can utilize that, and so this is just going to be an explanation of that problem that we left class with today. So here we've got two given thermochemical equations. So I've got propane reacts with oxygen to give us CO2 and water, and I've got a delta H for that reaction. So again, remember the difference between delta H and Q. Just want to reiterate that one more time. This delta H is for this reaction as this reaction is written. So we keep saying that. What does that really mean? It means if I take 1 mole exactly of propane and I react with 5 moles exactly of oxygen, I'm going to get this amount of energy out. That's the amount of energy that's going to be evolved. Down here, CO plus 1/2 O2 gives us CO2. Again, if this 1 mole of CO reacts with 1/2 moles of O2, this is the amount of energy that's going to be evolved. Now, for this problem, we're supposed to figure out how we can sort of modify these two equations up here in order to end up with this equation down here, and then figure out what the delta H for this unknown equation is. That's the whole point of Hess's law. The way that I would do this, rather than trying to do everything at once, right, which I think a lot of us are guilty of, we say, well, if I did this and I did this and I flip this over, and you try to see everything and solve everything all at the same time. Don't do that. Take your time. Be a little bit more, I don't know what the right word is. Deliberate? Yeah, be a little bit more deliberate. So the way I'm going to do this is I'm going to say, okay, well, what do I see in my product, in my final reaction, that I see, up here? And the first thing, we'll just start at the left-hand side, C3H8. So this is propane. Where do I see C3H8? Well, this is the only place up here that I see C3H8, and I notice in my final reaction I've got 2 moles of that product. So right away, I'm going to say to myself, well, it seems like for this reaction at the top, I'm going to have to multiply everything by 2, right? I want to times everything by 2. So if I did that down here, so let's just draw a line and sort of rewrite some of these reactions. I'm going to say 2C3H8 plus 10O2 is going to give me 6CO2 plus 8H2O. And then for my delta H, because I've multiplied this whole thing by 2, I need to multiply the delta H by 2 as well. So if I do that, I end up with minus 4439.8 kilojoules. So running out of space a little bit, but we get the idea. That's my number of kilojoules that I would have if I reacted exactly 2 moles of propane with 10 moles of O2. So this should be double, right? Because I'm sort of doubling how much propane I'm burning. Now, the next step, figuring out how to deal with this second reaction, what I'm going to do is I'm going to say, okay, O2 shows up here. I know O2 shows up here and here. So, it's going to be hard for me to sort of put that all together. So I'm going to skip over that. I'm going to say, well, here I see 6CO in my final reaction that I'm looking for. And the only source of CO in my two givens is right here. And I notice right away, well, this has a coefficient of 1. This has a coefficient of 6. Also, this CO is on the reactant side. This CO is on the product side. So to me, to sort of figure that out, that tells me I'm going to need to flip the reaction, and I'm going to need to multiply by 6. So flip times 6 is what I'm going to do to the second reaction. And if I do that, I'm going to rewrite it down here as 6 CO2 gas goes to 6 CO gas plus 3 O2 gas. So again, taking this reaction here and just flipping it and multiplying by 6 gives me this reaction here. For the delta H, I'm going to do the same thing, right? Flip the delta H is positive 283. Positive 283 times 6 gives me a delta H of 1698 kilojoules for this reaction here as written. So that's 6 moles of CO2 dissociating into these products. Now I'm going to add these two things together. So if I add these two equations together, right away I'm going to say, well, 6 CO2, that's going to cancel out on each side. If I've got 6 CO2 on this side and I've got 6 CO2 on this side, those are going to cancel out. Now, 2C3H8 gas plus I've got 10 O2s on this side and 3 O2s on this side. So I'm going to cancel out essentially 3 O2s from each side. So that's going to cancel this out, and that's really going to change this to a 7, right? 10 minus 3 is 7, plus 7 O2 gas is going to go to 6 CO gas plus 8 H2O liquid. So just double checking, this is the same exact reaction that I have here, so that's great. And then for my delta H, I'm just going to add these two values together, and I get my value of minus 2741.8 kilojoules. That is the final answer.